Hello guys, welcome to my YouTube channel. Today we discuss about logical equivalences. The definition of logical equivalences is the compound proportion P and Q are said to be logical equivalence if P implies Q. That is, P implies Q always tautology. Here we know that tautology means in the P implies Q truth table, the all values of the P implies Q truth table has to be true only. Then it is called as tautology, and it is denoted by this symbol and this symbol. Here some of the methods are used to solve the problem related to logical equivalences. The first method is we can solve the logical equivalences problem by using truth table. The second one, we can use the logical equivalent formulas or laws, and third one is the assumption method. We have to assume the whole problem and trying to be false it. If it is false, then the above statement is invalid. If it is assumption is our true, then it is called as valid. So here some of the formulas are equivalent law is, that is identity law. In identity law, if P statement and T equivalent to P only. Here P and true equivalent to P only, and second one is P or false equivalent to P values only. Second one is the domination law, that is P values or T values equivalent to T values only, that is true. And second one is P values and F values, P and F equivalent to F values only. If you do the truth table of P and F, we got the here same value is F values only, so these two are equivalent. The third one is the idempotent law, that is P or P equivalent to P. Second one is P and P also equivalent to P. The fourth one is the double negation law, that is negation of negation P equivalent to P only. Fifth one is commutative law. Here the connectives are same in two also, but the changes in reverse form, that is first one is P or Q equivalent to Q or P, and second one is P and Q equivalent to Q and P. The sixth one is the associative law. Here first one is P or Q or R equivalent to P or of Q or R, and the second one is P and Q and R equivalent to P and of Q and R. The seventh is distributive law, that means P or of Q and R equivalent to P or Q and P or R. Second one is P and of Q or R equivalent to P and Q or P and R. Eighth one is De Morgan's law. That is first one is negation of P and Q equivalent to negation P or negation Q. The second one is negation of P or Q equivalent to negation P and negation Q. Fourth one is negation law, that is P or negation P equivalent to true and P and negation P equivalent to F. Tenth one is the absorption law, that is P or of P and Q equivalent to P only. Here in absorption law we have some note, that is 1 and P equivalent to always equivalent to 1 value, and 1 or P always equivalent to P values. So these are the most important. So these are all are the most important equivalence law which are used to solve the logical equivalences problems. So let us discuss some problem by using the truth table and logical equivalence formula. Here given that let P, Q are two statements, find which of the following statements are equivalent. Here we have to use the truth table method and logical equivalent formulas method. So here given that first statement is compound statement is P or negation Q The second one is negation of negation P and Q. Third one is P and Q and P and negation Q and negation P and negation Q. The fourth one given compound statement is P and Q or P and negation Q or negation P and Q. So using first method 1, that is using truth table. Here first proposition is given that you have to find the P or negation Q. So let us start the problem. Take P values and Q values. Here two variables are there though. So 2 power n means two variables, 2 power 2 means that is 4. We have 4 cases, that is P have value true, false, false. Q has value true, false. So these are the 4 cases. Now we have to find the negation Q. That is true means these are the negation Q are the opposite values to Q value. That is true means here false, false means true, true means false, false means true. So here we have to find the P or negation Q. So P is the value is there and negation values are there, negation Q values are there. We have to apply the or negative connective. So in the or negative we know that P or Q, if P is false and Q is false, whole statement is false only. So in other cases all are true. So here one true is there, one false is there, so we get true only. Here one true is there, one true is here, one true is there and here also true is there, so it is true only. Here false is there, here also false is there, so here it's to be false. Here false is there and true is there, so it is true. This is the truth table of P or negation Q. Now the second one given that negation of negation P and Q. So here P value is there, we have to find the negation P value. That is negation P means here true, this negation P values is the opposite values of P. So here is true, here we false, true is there, false means true we have to write. Now here we have to find negation P and Q. So here we have negation P and we have Q values also. So negation P and Q, that means here negation P value is there and Q value is there, we have to apply it in between the and connective. In the and we know that P, Q and P and Q, if P value is true, Q value is true, the whole statement also true only. If in this case only we get true, in other cases we get the false value. So here see that here false is there in negation P and in Q true is there, so we get false only. Here is false, we get false only. Here is true, so it also true only. Here is true, here is true, here is false, so we get false only. Now we have to, here negation P and Q we find out. Here we have to find a negation of negation P and Q, that is negation of negation P and Q. So negation of this one is these are values of opposite values or these values. These values are the opposite to these values. Here true is there, so we write false is a true, false is true means false and false means true. So it is the truth table for negation of negation P and Q. So take it as equation number 1, this is number 2. Now we have to find the values of P and Q. Now take the third one, that is third one is P and Q and P and negation Q and negation P and negation Q. Okay, now do this separate. Take P, Q values, true, false, true, false. First of all we have to find the negation P values, negation Q values. So negation P, negation Q. it is negation p values are the opposite values to p values now. So here is true means here false, false, true, true, and negation q are the opposite values to q. So here is true, we write false, here is false, we write true, true means false, false means true. So now we have to do the p and q. First it is there not, so we have to find the p and q. That means p and q means in p values and q values we have to apply the connective is and. So in and we know that if two values are true, then only the whole statement is true. So here true, true means true, here is one true, one false, so these are all false in other cases. In this case only we have to take false, true. In other cases it will be false in and connective. Now we have to do the p and negation q. It is the p values all there, these are the negation q values. We are in between, we have to put the and connective. In and connective, if two values are true, then the whole statement is true. If with other cases are there, it will be false. So here true, false means false, and true, true means true, false, false means false, and false, true means true. Now we have to find the negation p and negation q. Negation p and negation q. Here negation p is there, negation q is there. In between we have to apply the and connective. In and connective, if two truths are there, then only the true, and it is other cases it will be false. So here false, false, false means false, false true means false, true false means false, true true means true. Now here we have to apply this whole statement, that is p and q and p and negation q and negation p and negation q. This is the whole statement. This compound values, this compound statement values, and this compound statement value, in three compound statement value we are applying the and connective. In and connective, if two truths, if pq values are true, then only the whole statement is true, otherwise false. So here you can see, here all are not in true, here all are not in t form, that is true form. So it is false. Okay, it is false. Yes, you can see false, true, false means false only. Here false, false, false means false. Here true, false, true, true means false. Okay. Here we have to this in between these three compound statements we have to use the or connective. In or connective we know that if p, q and p are q, if p is false and q is false, the whole statement is false. In other cases it will be true. Here in these three we see that here one true is there, so it will be true, and here also one true is there in between, so it also is true. It is all false, so it will be false, and here we are seeing one true, so it also is the true value. So this is the truth table for p and q, or p and negation q, or negation p and negation q. Here change the question, here I written wrong, here is or not and. Here also in the question change you, here also we have to put or. So this is the truth table for the third one. This is take as third. Now here fourth is what? P and q, or p and negation q, or negation p and q. So first of all here write p q value, that is true, true, false, false, q is true, false, true, false, and negation p, negation q values, right? Negation p are the opposite values to negation p are the opposite values to p, that is false, false, true, true. Negation q is the opposite values to q, that is false, true, false, true. Now we have to find first of all p and q, that is p values are here and q values are here. You have to apply the and connective. So if two truths are there, then only the whole statement is true in the and connect to truth table. So here two truths are there, true, and these are the false. One true, one false is there. Now we have to do the P and negation Q. So it is a P values and it is a Q values. Same applying the and connect to. We do the truth values of this. That is false, true, false, false. Now negation P and Q. It is the negation P values and these are the Q values. We have to apply in between and connect to. So here true false means false and false false means false only. True true means true and false true means false only in and. Now here is a P and Q or P and negation Q or negation P and Q. These are the three compound statements. In between we place the or connective symbol. So in these three we have to see that if all false is there, then the whole statement is false. So here one true is there, so it will be taken as true. Here also one true is there, it will be false. This is the truth table for fourth one. So here you can see here in first truth table what have true, false, true in first question. You can see here, and you can see in second also, in second problem also, negation of negation P and Q. Here also is there true, false, true. These two are equal, equivalent to this. And you can see in third one, here also you can see true, false, true. That is this third one is equivalent to 1, 2 also. Here coming to fourth one, here you can see true, false is there, so it is not equal. From the above question, here asked that find which of the following statements are equivalent. So from the above question, first one equivalent to second one and second one equivalent to third one, and first, second, third not equivalent to fourth equation. This is the above problem and solution for the above question using truth table. Coming to the second method for this problem, second method was it logical equivalent problem. That is coming to the second method, that is method 2, using logical equivalence, using logical equivalence. So first one is what given here, P or negation Q. Put this like this only. Take the second one, that is second one is negation of negation P and Q. This is, by seeing this you can remember that this is in the form of double negation law. That is double negation law. That is using here double negation law formula, that is negation of negation P equivalence to what, P only. So by using this formula here we get negation of negation means negation cancel, here P, and this negation is applied to this, that is P and negation Q. This is the second one. By taking third one here, third one given that P and Q or P and negation Q or negation P and negation Q. Here in these two you can see here P is common, so take P as common, P, and here taking P as common we get P and Q or negation Q or negation P and negation Q. Here you can see that it is in the form of negation law. So here negation law means Q or negation Q equivalent to Q only. So by applying this formula here we get P and Q or negation P and negation Q. So here P or negation Q formula is there, Q or negation Q is true na. So by placing this formula here we get here value is true, P and true, here P and true or negation P and negation Q. here this is the identity law. By using identity law in this place identity law is P and through means equivalent to P and through equivalent to P only. By using identity law in this P and through place is substituting P or negation P and negation Q. Okay, here it is in the form of distributive law, that is this one is in the form of distributive law. Distributive law, what is the distributive law? We know that P or Q and R equivalent to P or Q and P and R. This is the distributive law. By using take is P and take is Q and R, by using this formula we write P or negation P and negation Q. Here P or negation P is the negation law. You can see here negation law is Q or negation Q equivalent to T. So in this place we write T and P and negation Q. Here take P and negation Q take as P. So in identity law P and T equivalent to what value? P only. So here P, by using this here this formula we write value is what? P. So P value is here P and negation Q. So it is the answer for third one. So coming to the fourth one, that is P and Q or P and negation Q or negation P and Q. Here same as here P is common in these two, so take P as common and Q or negation Q or negation P and Q. Same as here third one, here Q or negation Q is in the form of negation law. So in this place we write P and T or negation P and Q. So here P and T is in the form of identity law, you can see. So in this place we substitute P or negation P and Q. So take here applying distributive law. So take is it is assume as this P Q R, we get by using distributive law we get P or negation P and P or Q. So here P or negation P is in the form of same as negation law, so take is here as T and P or Q. Here let us assume this as P. It is in the form of P and T, so it is called as identity law. Here P and T equivalent to what? P only, so it is the value of P. So here this answer get as P or Q. It is the answer for fourth one. So here you can see here first value is P or negation Q for first compound statement, and here for second compound statement also the value is P and negation Q. For third compound statement the value is P and negation Q only. For fourth compound statement value is P or Q. So by using logical equivalence method for this problem, here we conclude that here first one is equivalent to second one and second one is equivalent to third one, and these three are not equivalent to fourth one by seeing their values. So you can see here this value, this value, this value and this value. Hope guys you understand that both method, that is using truth table method and logical equivalence method. Hope you also like the video guys. Like, share, comment and subscribe and click the bell icon to be notified every update from my Smart Studies YouTube channel. Thank you guys. Hello guys, welcome to my YouTube channel. Hope you people like the video. Keep supporting me by subscribing the YouTube channel and like, share, comment and click the bell icon to be notified every update from my Smart Studies YouTube channel. Thank you guys.